So here at the stand of the University of Essex and with Dr Andy Simkin, who's the Director of the Essex Plant Innovation Centre. Andy, what are we showcasing here?
I think one of the big things we're showcasing is our new facility at the University of Essex, which is the Wolfston STEPS, stands for Smart Technology Plant Suite. And it allows us to look at different growing conditions and see how we can improve plant productivity, so increase our food production by at the same time reducing the required inputs. So one of the things we actually have at the University of Essex is an IAG grow frame. So this is a vertical farm. It allows us to basically look at how growing crops in these vertical systems, how we can improve quality by reducing the amount of inputs. Specifically, in this sort of grow frame, we can actually grow crops using approximately 80% less water than maybe would be used in something like a traditional greenhouse. It also allows us to reduce other energy inputs, such as the amount of light required. Plants require red light to grow, but not necessarily all the other light that's out there, which is just a waste of energy when we're trying to grow plants. So we can control the light recipes in here so that plants can have exactly what they need and exactly the right energy inputs to give us the product that we need in order to feed people. And these growing systems are becoming far more common now, so it's important for us to understand how growing food in these systems affects the quality and the nutritional requirements that needed by people that then are going to consume these products. The steps, Wolfston STEPS also contains a couple of other important rooms which aren't showcased here. One of those is what we call the dynamic field. So the dynamic field is a room which mimics the environment outside on a second-by-second basis. So we can connect it to sensors anywhere in the world. Essex is actually connected to a sensor on the roof, and that room can then mimic whatever the conditions are outside the building, adjusting the light, the humidity, the temperature on a second-by-second basis. And that allows us to really study plants in a natural environment rather than just in a growth room, which doesn't really mimic how plants grow in the real world. And that is probably one of the best pieces of, one of the best rooms we've actually established within the Wolfston STEPS. One of the other parts of it is also how we can study how climate change will vary or change or affect plant growth in the future. As most people know, CO2 levels are increasing. They're currently around 427 parts per billion. And if we remember that before the Industrial Revolution, levels were around 284 parts per billion, we can see that CO2 levels are increasing. And we expect those levels to increase to about 550 parts per billion by 2050. So in this facility, we can have multiple rooms where one room is growing a crop at current CO2 levels, current atmospheric conditions at 427 parts per billion, and then compare that to a same crop grown in a room where everything else is identical except for the CO2 concentrations. And we can grow that at 550 parts per billion, which is what we expect CO2 concentrations to be in the atmosphere by 2050. So it allows us to make a direct comparison of how changing environment is going to affect crops we grow and how it might potentially affect the quality or the yield of that crop.
Brilliant, thank you.